right, you guys, so I wanted to do a quick video so you're feeling better about our test tomorrow that goes over the test review. For the following graph, list the intervals where the graph is increasing and decreasing. So you can do this any way you want. If you want to do it the way you will be doing it in pre-calculus, I'll show you that when we're done. But just to start off with, we can just make a table that we have like, let's see, and oops, what am I doing here? Pen. Oh, that's orange. I don't want to do orange. Okay. So where is it increasing? Okay. And where is it decreasing? And it is increasing here, obs, and again here, and again here, right? And it's increasing because it's getting higher on the y-axis. But what it wants us to write down is which part of the domain is it increasing in? And that's going to be always the x values, right? So where is it increasing? It's increasing from, I think this is -5, right? And this is -3. So it's increasing from -5 to -3. It's also increasing from -1 to +1, right? -1 to +1. And it's also increasing here, let's see, 1, 2, 3, from 4 to 5, both positive, right? 4 to 5. Okay, now if you want to write that in interval notation, you would say it is increasing from -5 to -3, union, and always in order from the lowest x value, that's why I put -5 first, to the highest, which is +5 here, right? Union with -1 to +1, union with 4 to 5. Okay, and that's how you'd write it in interval notation, the square bracket, because it can actually be those points. But if you just want to write it over here like this, that's fine too. So then where is it decreasing? And this is a little bit tricky. This line has an arrow on the end of it, which means it goes on and on and on and on till -infinity, right? So it's decreasing, that first part is decreasing from -infinity to -5, and also from +1 to +4, so from 1 to 4, it's decreasing. Okay, and the question didn't ask where it was constant, but some of you wrote down it's constant here until infinity, which is correct, and it stays constant here from -3 to -1. All right, what's next, you guys? Oh, okay. Which graph matches which storyline? And I didn't write the storyline down here, but I can read that to you. All right, you guys, so let's read some of these stories. Story number 1 says, Kelly and Cindy sprinted from one end of the gym to the other, then they jogged back to where they started. Cindy sprinted faster than Kelly. So if you guys look at all of these, sorry guys, all of these questions have distance here on the y and time on the x. So the distance here keeps getting greater, right? The distance here gets greater, stays the same, and then goes down. So the rest of these are the same. The distance gets greater and then comes back. So all of these people are going somewhere in these last 3 and coming back to that same place, okay? So which one is it? Well, let's see. Let's look at some of these units. This is miles here for B. For C, it's miles. And for D, it's meters. What makes the most sense in a gym? okay? And that's going to be meters. So the first story, story 1, is going to be D, right? Story 2 says, John walked to school. The second half of his walk was uphill, so he walked at a slower pace. So it's only one way. We already know what this is. He doesn't come back. He was started here, and then he walked at a little bit of a slower pace here. So story 2 is going to be A. Story 3, Rachel drove to the dentist's office. Her appointment lasted for 45 minutes, and then she headed home. So what do we have left? We don't need D, we don't need A. It's one of these. I mean, obviously it's going to be B because it's only one person, and her stay at the dentist office for all that time means she's not going anywhere. So she gets there, she's at the dentist office, then she comes back. Okay, and 4 must be C. 2 people are running and back. Okay. Question 3, write a graph of the function g of x obtained by shifting the graph f of x equals x squared 3 units to the left. So let's take this one at a time. 3 units to the left would be adding 3, okay, to the inside by the x, stretching the graph vertically by a factor of 2. That's going to be multiplying the outside by 2. Because that's the vertical. Reflecting the result over the x-axis, that means we make this negative. And then translating the graph up 4 units. Okay? So that's going to be our new f of x after we do those things. Okay. Create your own graph, so everybody's should be different. Oh, this is g of x equals. So let's do that again for B. So we have the square root of x, and you know that's going to be like, the parent function is going to be like this, right? You can always find the parent function by just putting this into the calculator and looking at what the graph looks like. G of x, let's see, what do we want to do to this? How about we flip it over the y, and to do that, we make the x negative. How about we move it to the right 2? We vertically stretch it, or how about we vertically compress it by multiplying by 1/2? And then we move up by 3, okay? And then you just need to write those steps that you did, okay? We reflected it over the y, we moved it to the right 2, we vertically compressed it by 1/2, and we moved it up by 3. So you should have 4 steps written down of what you did to this equation. Okay, and you can always use your calculator to check, like I said before. So I typed it into my calculator. The first one I typed the parent function, which was just the square root of x. The square root is second x squared. And then I did all of those things I said I would here. And then I just gave it a standard zoom, zoom 6. Okay, and there's my square root of x. And there's my opposite. So we moved it over 2, up 3, stretched it, and flipped it over on this side. So you can always check your work by seeing what happens. Or if a question is asking you what's happened to a graph, you can graph it and visualize what happened there, okay? So use your calculator, it's a tool. Okay, this one, the bottom two, you may have realized I forgot to write down something to do. So how about for this one, we do f of x minus 2. So we're moving it horizontally. And this one we do f of x plus 3. Since it's on the outside, we are moving it vertically. Let's see if I can make this picture bigger. Bear with me while I figure out how to use this. Grab it. You guys, look. Cool, that's gonna be better. Okay. Yeah, but now what do I need to do? Now I need to erase what I wrote and then rewrite it. Okay, so in this one, this is saying my f of x, which is my output, right? Sorry about that, is negative. So my output is my y, and we're making every y negative, but my x stays the same. So here's a point here, right, which is 1, 2, 3, 4, negative 4, 0. Well, that one stays the same because 0 can't become negative. So let's try this one. Here, my x is negative 1. That's going to stay the same, but instead of negative 3, my y is going to be 1, 2, 3. Positive 3, okay? And then 0, 0, that's going to stay the same. And my x is going to stay same too here, but instead of 6, it's going to be negative 6. 1, 2, 3, 4, 5, 6. Boom. So down here, and then it's going to stay here, okay? So your graph should look something like this. This one, since it's on the inside, means we make every x negative, but the y stays the same. And what that's going to do is it should just flip it over the y-axis. So this one flipped it over the x-axis, and this one will flip it over the y-axis because my y stays the same, but my x will change. So instead of negative 4, 0, it's going to be positive 4, 0. Okay. Then instead of negative 1, negative 3, it's going to be positive 1, negative 3. Okay. And instead of 2, 6, it's going to be negative 2, 6. And then the same. Cool. See how we just reflected it over the y here? Okay, if we would have folded it right there, that's where it would have been. You can also make a table, like if my original input, my original output, and then my f of negative x. So here, negative 4, 0, okay? And then my other answer is going to be f of negative x. So instead of putting negative 4, I put positive 4 in. But I have the same y value here, okay? Okay. Let's do this one. This means I'm going to move every x to the right 2. So all you have to do is move this point 2, move this point 2, move this point 2, move this point 2. You're not really going to see that, but okay. And this one means we just move every y. Oh, I didn't give myself enough room. Up 3. Okay. is a composition problem, and I said this in class, and there is a little bit of a difference here, but I'm not going to worry about it because we're not going to get into the nuance of this for a little bit. So like I said in class, just rewrite this as f of g of h of x. Make sure we get all of our parentheses in. Start from the inside out, so this open circle means composition. Start from the inside out, so we start with h of x, okay, which is just x minus 2, right? So f of g of x minus 2, okay? Now I need to find g of x minus 2. So g of x is 2x, so g of x minus 2 means everywhere I see an x, instead I'm going to put x minus 2. So this whole thing is g of x minus 2. So what I need now, what it wants me to find, is I can enter that in here, right? So g of x minus 2, this whole thing is the same as saying 2 times x minus 2. Okay, so now I need to find f of 2 times x minus 2. And if you want, we can make that simpler by distributing this 2. So if we distribute that 2, we get 2x minus 4. So that's okay. We can do f of 2x minus 4. Okay. So what that means is our original f of x is just x squared. So if I make this whole thing as my x, right, x squared, and I just made it really big because I'm going to erase it, because instead of x, I'm going to put 2x minus 4. Okay, that is f of 2x minus 4, which is also the answer to f of g of h of x equals this final answer here. 5b, find f of g of 2. So first of all, I put g of 2 equals, instead of 5 times x, I have 5 times 2 plus 3. Order of operations means I multiply first. 5 times 2 is 10. My final answer is 13. Okay, so that's my g of 2 is actually 13, right? So I'm going to change that to be f of 13. Now, f of 13 is simply, instead of x, we put 13 minus 2, because f of x is x minus 2. And my final answer is 11. So the actual numerical value for A is 11. Okay. Now g of f of negative 4. Let's see here. Starting with the middle, f of negative 4 means instead of x, I do negative 4 minus 2, which is negative 6. Now I want to find g of negative 6. So 5, instead of 5 times x, I do 5 times negative 6. Plus 3, order of operations gives me negative 30 plus 3, negative 27. Okay. let's see, race. F of 1, what? F of 1 is going to be 1 minus 2, which is negative 1. So that means then we have to do f of negative 1. Oops, sorry guys. Wrote that in a bad place. Then what I want to do is f of negative 1 equals negative 1 minus 2, which is negative 3. And lastly, but not leastly, what does this icon do? I don't think I should touch it in the middle of a recording. F of g of x, no numbers, oh no. Well, I already know what g of x is, 5x plus 3, right? So that means I want f of 5x plus 3, which just means instead of x, I put 5x plus 3 minus 2, okay? And you can put that in parentheses, but since you don't have anything multiplying the parentheses or being squared, you can always just simplify that to 5x, and then positive 3 minus 2 is plus 1. Yay, almost done, you guys. You guys are going to rock this test. I just know it. Sketch and describe an even and an odd function. Okay, you guys. So an even function I wrote on the board is something like x squared. And you can kind of tell it's even because the degree is even. It's a 2, it's even. But what does that parent function look like? We know that parent function is a parabola, okay? And both ends of your equation, if you go positive, it's increasing, and if you go negative, it's also increasing. So both of the ends of the function are doing the same thing. Even if you had negative x squared, right, it just simply flips this over here. And now both of my ends are going smaller, right? They're both going towards negative infinity here. But increasing and decreasing, you guys know, like, it's increasing to here, and then it's decreasing. What I mean by the ends are doing the same thing is they're pointing the same direction, okay? The function itself is increasing and then decreasing. Okay, so that makes this an even function, even if it's negative x squared. And an odd function would be, like if we look at the parent function for x cubed, which is just this is probably a little more symmetrical there. It's the whole thing is always increasing or always decreasing, right? Oh, that's not true. I just lied to you again. But what it starts off increasing and it ends up decreasing. Here, it's going up and then coming down and then going up again. But our ends are doing different things. This end is going towards positive infinity, and this end is going towards negative infinity. And this is the parent function for x cubed. If we look at the parent function for negative x cubed, it just flips it over here. Right? Okay, so even though now as x goes to positive infinity, y goes to negative infinity, and then the opposite is happening here, okay? The important part is that the ends are going in different directions. So that was negative x cubed. I should highlight the negative x cubed is this one. Okay. And that's an odd function where the ends are doing different things. They're going different directions.